Welcome to today's video voiceover of the solutions to your practice final exam problems. The first problem is review from functions. It just asks you have an average sale at a floor shop is $25. So the weekly revenue function R of X, which is 25 times X. X number of flowers are sold each week at $25. So X is the number of sales in 1 week. Corresponding weekly cost function is C of X is 9X plus $600, where, again, X is the number of sales. And the question here is, what is the florist shop's weekly profit function? How much profit is made when sales are $120 per week? If the profit is $1,000 for the week, what is the revenue for the week? So the first question here, profit, remember profit is just equal to to revenue minus cost. So the function P of X is just going to be equal to revenue minus cost. Revenue here is 25X. And cost is 9X plus 600. What's 25 minus 9X? That is 16X. So the profit function is 16X minus 600. Next question, how much profit is made when sales are 120 per week? So here, this is just a matter of plugging X equal to 120 into this function, 16X minus 600. So the P of P of 120 equals 16 times 120 minus 600. Now 16 times 120 is 1200. That's 10 times 120 plus 600, that's 6 times 100, plus 120, that's 6 times 20. So that's the same as, so now you can actually see what's going on here. We subtract this 600, these 600s cancel, so what we're left with is just 1,320. Now, the next question asks you, the final part of this question, what is the revenue for the week if the profit is $1,000? So what we can do here is, well, if the profit was $1,000, that means that 16X minus 600 is 1,000 That means it's 16x equals 1600, or x equals 100. So if x is 100, we plug this back into the revenue function to get r of 100, which is equal to 2,500. There we go. Okay, the next question is to simplify this exponential expression. So here, 6 times x to the 7th over y to the negative 3. Our job is to simplify this. And when to simplify this, if you remember from laws of exponents, when you're dividing two expressions and raising that whole expression to an exponent, you can raise that's equivalent to raising the numerator to that exponent, and then dividing the denominator raised to the same exponent. So what we end up with is the following. 6 to the negative 3 times x. So actually, before we do that, remember when you raise an expression to the negative 3, that's the same as raising this whole expression, 6x to the 7 over y. That's the same as raising the reciprocal of this expression to the third power. Now the reciprocal of 1 over 6, which is 1 over 6 x to the 7th over, over y, that's the same as just y over 6x to the 7th. We raise this to the third power. So it's the same as y to the third over 6 raised to the third power ends up being 216, and x to the 7th raised to the third power is the same as x raised to the 21. That's because laws of exponents, x to the 7th raised to the third power is the same as x to the 3 times 7, which is 21. Okay, so that's how we simplify that exponential expression. Now, the next question is about finding the composite function. F of x is x to the 5th, and g of x is input and spits out that. So what we should do to find the composite function f composed g of x is substitute g of x in place of x in the expression for f of x. So now when we perform this operation, what do we get? Well, remember f, like I said, takes an input and raises that input to the 5th power. So if f takes g as an input, it will take the function x cubed minus 4x squared plus x minus 8 and raise that whole b to find the composite function each x for each x in g of x. Perform the operation in the previous step. So g of f of x, now the function g is, when we write down functions, f of x equals x to the fifth, and g of x equals x cubed minus 4x squared plus x minus 8, this is saying x is just a placeholder for input. The function f is defined as taking an input and raising that input to the fifth power. Likewise, the function g is defined as taking an input, raising the input, putting 4 times the input squared, adding the input, and subtracting 8. So let's see what happens. If g is now taking f as an input, well, we can plug in the input, raise it to the third power, subtract 4 times the input, raise it to the second power, add the input to the fifth power, and subtract 8. So when we perform this operation, what we end up getting is x to the fifth cubed, which is x to the 15th, minus 4x to the fifth squared, which is x to the 10th. Okay, so we're just multiplying those exponents. So if we recall, x to the fifth cubed is the same as x to the 5 times 3. So that's the same as x to the 15th. Likewise, x to the fifth squared is the same as x to the 5 times 2. So what is that? That's the same as x to the 10th. So therefore, g of f of x is x to the 15th minus 4x to the 10th plus x to the 5th minus 8. Okay. Next question, and this the graph functions and derivative functions to find the critical numbers. So this is asking you to factor the polynomial. This is just a degree 2 polynomial or quadratic function, x squared plus 14x plus 33, x squared plus 14x plus 33. It's the same as x plus 11 times x plus 3. Now, why is this the case? Well, to factor this number, we need to find two numbers that add up to 14 and multiply to 33. 11 times 3 is 33, and 11 plus 3 is 14. So 11 plus 3 is 14. 11 times 3 is 33. And therefore, the quadratic function x squared plus 14x plus 33 is equal to x plus 11 times x plus 3. This next question asks you whether or not that in order for a function to be differentiable at a number, this limit, this difference quotient, has to exist. The limit as h goes to 0 of f of a plus h minus f of a over h. If it's suspected that f of x is not differentiable at a, then it is easier to use the relationship between continuity and differentiability to prove that f is not differentiable at x equal to a. So all this is saying is that differentiability implies continuity, and therefore being not differentiable at a implies it's not continuous at a. I'm sorry, not being continuous at a implies that it's not differentiable at a. So if f is differentiable, the function must be continuous. Like we said, differentiability implies continuity. So you had a homework problem where you were asked, actually, you had a function that was like this, and you were asked, okay, is the function is defined piecewise, it's an expression for x not equal to 11 in this case, and it's 9 for x equal to 11. And then your question is, well, is the function continuous, and is the function differentiable at, say, x equal to 11? So if that was the question here, this is just asking about differentiability, but we could just also ask about continuity. Now, to determine continuity, we have to see, okay, does the limit as x go to 11 of f of x exist? And if so, is it equal to the value of the function at 11, which in this case is 9? Now, x squared minus 9 minus 9x minus 22. We factor this, we get x minus 11 times x plus 2. So the x minus 11 factors cancel. We're left with x plus 2, provided x is not equal to 11. When you plug in x equal to 11, 2x, in this expression x plus 2, what we get is 13, right? 11 plus 2 is 13. So what we just found was that the limit as x approaches 11 of f of x equals 13, which is not equal to the value of the function at 11, which is not. That was just given to us. So that means the function's not continuous, and because the function is not continuous, it is not differentiable at x equal to 11. And that's what's going on here. So it says the easiest way to prove non-differentiability is to prove that the function fails at the property discussed. The given function is continuous at x equal to a, provided what limit exists. It's provided the limit what limit is true. Limit as x goes to a of f of x equals f of a. This is the definition of continuity. Now, there's really three statements in that one equation. One is that this limit on the left-hand side exists. The other is that the function is defined at a. And the third is that these two expressions are equal. Now let's calculate the limit. So this is what we just did. Calculate limit x goes to 11 of f of x. Since as x approaches 11, x is not equal to 0. This rational expression, and the rational expression, the numerator can be factored. And what we get is x plus 2. Plug in x equal to 11 into the x, and we get 13. Now, okay, well, what's f of 11? That's just given here. When x is 11, what's f? It's 9. Compare the results. In the last two steps, decide if f of x is continuous at 11. Is f continuous at 11? No, it's not continuous because the value of the function at 11 is not equal to the limit as x approaches 11 of the function. And because it's not continuous at x equal to 11, it is therefore not differentiable at x equal to 11. So remember, that wasn't your homework. If a function was not differentiable at a given number, if a function was not continuous at a given number, then it was not differentiable at that number either. Next question, write the equation of the tangent line to the curve y equals x cubed plus 3x minus 2 at 1, 2. So here, if you recall, to find the equation of the tangent line, we need to find the slope. The slope of this tangent line is going to be the value of the derivative evaluated at x equal to 1, the x coordinate. Y prime, we can just differentiate each term using the power rule to get y prime is 3x squared plus 3. And then when we plug in x equal to 1, 3x squared plus 3 becomes 3 times 1 squared, which is equal so minus our slope m is equal to positive 6. If our slope is positive 6, y minus 2 equals 6 times x minus 2. So that means that y is equal to 6x minus 12 plus positive 2, which is equal to 6x minus 10. I'm sorry. Y minus 2 is equal to 6 parentheses x minus 1. When you distribute 6, you get 6x minus 6, and we're adding 2. So what we end up with is 6x minus 6 plus 2. That's the same as 6x minus 4. Next question is find the slope of the tangent line to the curve y equal to x squared minus 15 to the 7th at x equal to 4. Then write the equation of this tangent line. So same problem, but in this case, differentiating this function requires the chain rule or equivalently the generalized power rule. Now, what's the slope of the tangent line? To find this, we need to differentiate this function, x squared minus 15 raised to the 7th power. What is the derivative of this function? It's y prime equals 7 times x squared minus 15 raised to the 6th power times 2x. Plug in x equal to 4. What we end up with is 7 times 16 minus 15, which is 1, times 4. So that's the same as 7 times 1 7 times 1 raised to the 6th power times 2 times 4, which is equal to 7 times 1 times 2 times 4. That's equal to 7 times 8, which is equal to 56. So our slope is 56. Now, when x is 4, we saw, well, look, x is squared is 16. 16 minus 15 is 1. 1 to the 7th is 1. So the point here, we have our slope here. This is our slope. This is m. Specify a line on the tangent line. In this case, we need a slope m and a point. In this case, 4, comma. So we have our slope is 56, and the point is 4, comma 1. So y minus 1 equals 56, the slope, times x minus 4. It's the same thing. It is the point slope formula. Now, if you want, of course, you could distribute this 56 to the x and to the 4 and add 1, and what you get would be the equivalent expression or equation to this equation. Y minus 1 equals the slope of 56 times x minus 4. Okay. So, next question asks us, we have the limit below is the definition of f prime. Our job is to determine the function f of x and the value of a. Limit h goes to 0 of 1 over 25 plus h minus 0.04 over h. So notice, okay, we want to rewrite this limit as limit h goes to 0 of f of a plus h minus f of a divided by h. Now, if you notice, a plus h, what do we have on the left-hand side in the numerator? The leftmost term is 1 over 25 plus h. F prime of a, therefore, is, so our guess for what f of a plus h is going to be, this is a guess, we'll determine if we're right if all other terms work out, is 1 over 25 plus h. Now, a means a, we're going to guess is 25. Now, let's see if that works out. A is 25. What's f of x? That means f of x is 1 over x, right? Okay, so that ends up being correct. Let's see why. Well, we saw if f of x is 1 over x and a is 25, then 1 over f plus a is 1 over 25 plus h. Now remember, what are we subtracting? We're subtracting f of a from f of a plus h. It's the difference in outputs, the difference of the output obtained when the input is a plus h, and when the input is a, divided by the difference between the input at a plus h and the input at a. So the difference between f of a plus h and f of a is we saw the leftmost term was 1 over 25 plus h. Now, if a is 25 and f is 1 over x, what's f of a? We're subtracting 1 over 25. And it turns out 1 over 25 is the same as 0.04. And then we're going to divide this whole expression by h. So this ends up being correct. The function is 1 over x, and the input, where we're evaluating f prime of a, the limit of the difference quotient, is just 25. Next question is to determine the following limit if it exists, and compute the limit if it exists. So this is the limit of x squared minus 16 over x plus 4. Now notice when we plug in x equal to negative 4, what do we get? We get 0 over 0. Now we saw in class towards the beginning of the semester that 0 over 0 is undefined and actually really can be any real number. So this limit might exist, it might not exist. We have to check if we can simplify this expression using algebra. X squared minus 16 factors into x minus 4. It's the difference of two squares, x minus 4 and x plus 4. When we divide x minus 4 times x plus 4 by x plus 4, what we end up with is x minus 4. Now when we plug in the number, negative 4, into the expression x minus 4, what we end up with is negative 8. Negative 4 minus 4 is minus 8. And there's our answer. The limit in this case does exist because we could simplify this function using algebra and plug in what the input is approaching, negative 4, and get a real number. In this case, what we get is negative 8. Next question. The graph of the function has one relative maximum and one relative minimum point. Plot these 2 points and check the concavity there. Using only this information, sketch the graph. So here, how do we find relative maximum and relative minimums? We differentiate a function and we find the critical points. So what's the derivative of this function? It is 3 we differentiate this function, what we end up with 3 x squared minus 12x plus 9. We can factor out a 3 to get the following. 3 parentheses x squared minus 4x plus 3. So that's the same as 3 times x minus 1 times x minus 3. So the critical numbers are 1 and 3. So I'm just writing C numbers for short here. Now, if you recall from the second derivative test, we can determine whether or not a critical number is a relative max or a relative min using the second derivative. Now, the second derivative of this function, so remember f prime, what is f prime? It was 3 x squared minus 12x plus 9. So when you differentiate that again, 9 is constant. So that term, its derivative is 0. We're left with 6x minus 12. When you plug in 1 to 6x minus 12, you get a negative number. It's equal to negative 6, which is less than 0. When we plug in 3, we get 6 times 3 minus 12, which is the same as 18 minus 12, which is the same as 6. 18 minus 12 is 6. So if 18 minus 12 is 6, that's positive. That means we have a local minimum. So the relative minimum point is 3, 0, because at x equal to 3, f double prime, we just saw the value of f double prime was positive 6, which is positive. That means the graph is concave up. So remember, a positive second derivative means the function has the shape of being concave up, or smiley face. And concave up means a local minimum, right? The smile has a lowest point. Smile or a valley has lowest point. That corresponds to the second derivative being positive. The relative maximum point in the graph is 1, 4. So when we plug in 1 to this function, we get 1 minus 6 times 1, which is negative 5, plus 9, which is 4. since the value of f double prime at this relative maximum point is -6, right? So we saw it was 6 times 1 minus 12, which is -6. The graph is concave down there. That means concave down is like a frown or a hilltop. A hilltop has a peak, which is a local maximum. So local maximum, and remember when we're asked to find a relative maximum point, we're asked to specify not only the x-coordinate, but also the y-coordinate. And that's just, the y-coordinate's obtained just from plugging in 1 to the original function here. Not the derivative or the second derivative, but the original function. Now to graph this, what do we know about this? Let's see. So if we're using this information, sketch the graph. What do we know? It has a local max at x equal to 1, 1 comma 4. So, and then it changes to having a local min at 1, 3 comma 0. So it's going to look something like this. And because it's 0 at 3, it's going to pass through the x-axis there. So it's going to look something like this. Let's see which of those graphs that we can choose meets up. Well, this has a local minimum first, then a local maximum, so it's not this one. This has a local maximum, but the point is incorrect. It doesn't, it has a, so remember, it has a local max at x equal to 1, not x equal to 0. And here it's showing it has a local min at x equal to 2. That's not right either. Here, it's wrong as well. It doesn't have a local min at x equal to 1 or x equal to 0 and a local max at x equal to 2. This one, however, is correct. So here, this is showing, okay, yes, it does have indeed a local maximum at x equal to 1. So these are 2s, 2, 4, 6, and 7 here. So local max at x equal to 1, and then changes to local min at x equal to positive 3. Sketch the following curve indicating all relative extreme and inflection points. Y equal to x cubed minus 3x plus 4. So to sketch this, remember, we need to differentiate the function. When you differentiate this function, you get 3x squared minus 3. This means the critical numbers, right, are -1 and +1, because when you set this equal to 0, what you end up with is -1 and +1. When you set this equal to 0 and solve for x, what we end up with is x squared equal to 1. That's the same as x equal to plus or minus 1. So we get -1, +1. And now we're going to check, okay, well, if when f prime is less than -1, f is what? It's positive. When it's between -1 and 1, it's negative. When it's larger than 1, it is positive. Test number here could be, say, -2. You can check that. When you plug it into f prime, what you get is a positive number. You plug in 0, 0 minus 3 is -3, which is negative. When you plug in, say, 2 here, positive number, which you get as a positive number here. So that means it's going from increasing to decreasing at x equal to -1. And it's going from decreasing to increasing at x equal to 1. So it has a relative extreme point at -1 comma 6 and 1 comma 2. In particular, -1 comma 6 is a max. So negative 1 comma 6 is a local max, and 1 comma 2 is a local min. Inflection points. To find the inflection points, we need to find y double prime. Y double prime is equal to, in this case, 6x, and 6x is 0 precisely when x is equal to 0. So the number 0 divides the number line into exactly 2 subintervals, and y, if we look at y double prime or f double prime, when x is less than 0, pick your favorite number less than 0. So remember, y double prime was 6x. We get a positive number. And we pick we get a negative number when x is less than 0. We get a positive number when x is larger than 0. So negative, positive. And therefore, the graph changes from concave down to concave up precisely when x is equal to positive 4. Precisely when x is equal to 0. When x is equal to 0, the output is positive 4. So now we have information to sketch our graph. When x is between negative infinity and negative 1, the function is increasing concave down. When it hits negative 1, the function is now changes from increasing to decreasing, but remains concave down until we hit 0. That's the inflection point. Local max, inflection point. And then, so here's our max. We'll write IP for inflection point, and here's the min. So it changes from decreasing concave down to increasing concave up at x equal to 0. And then it changes from decreasing concave up to increasing concave up at x equal to positive 1. That's where it has the local min. And let's see a little further so you can see what's going on. Okay, the graph of the following function is shown to the right for x larger than or equal to 0. Find the coordinates of the maximum point. So here, to do this, we need to differentiate this function, set the derivative equal to 0, and then that will give us the critical numbers, and we need to say, okay, well, for which critical number is this function changing from increasing to decreasing? So it looks like it has, from the graph, it seems like it just has one critical number for x larger than 0, and we can determine what that is from differentiating. Y prime is what? It's the derivative of the numerator, which is 12, times the denominator, which is 1, plus 0.25 x squared minus 0.5 times 12x. 12 times 1 plus 12 times 0.25x squared. That's the same as just 12 plus, well, let's see, what's 12.25? 0.25 is the same as a fourth, so that's 12 plus 3x squared. Now we're subtracting, well, 0.5 times 12x, that's the same as 6x. So let's see what this is. It's 3, we can factor out a 3 here. We get 3x squared minus 2x plus 4. And we can recognize that x squared minus 2x plus 4 is the same as x minus 2 squared. And of course, the denominator is just going to be this thing squared. Now, 1 plus 0.25x squared is never 0 because x squared is always larger than or equal to 0. Because x squared is always larger than or equal to 0, 1 plus 0.25x squared is always larger than 1 or equal to 1. So if this is 0, that means that x is also equal to 2. So the critical number is x equal to 2. So actually, for that part, we can say we're pretty much done because we see from the graph that's the only critical number, and it has a local, or in this case, actually not just a local, but an absolute maximum point for the interval from 0 to infinity at x equal to 2. When you plug in x equal to 2 to this original function, what you get is 12 over 1 plus 0.25 times 2 squared. I'm sorry, 12 times 2, which is 24. Over 1 plus 0.25 times 2 squared, which is 1.25 times 4, which is the same as just 1/4 times 4, which is 2. So we get is 24 over 2, which is equal to positive 12. So the maximum point is 2, 12. And you could also check, okay, that the function, so if you recall, remember it was three times x minus 2 squared in the numerator over 1 plus 0.25x squared in the denominator. When x is equal to positive 2, okay, so when x is less than 2, this is positive. When x is larger than 2, what we should get is something negative. So in any case, the point is this just has one critical number that corresponds to the local maximum. should be able to check. So $12 times the numerator is 12 times 1 plus 0.025 squared minus 0.5 times 0.5x times 12x, which is the same as 6x squared. So I apologize. The numerator it wasn't exactly 3x times parentheses x squared minus 2. It was minus 6x squared plus 4x squared. So it is 12. Well, it's 12 minus 3x squared. Or if we factor out a 3 times 4 minus x squared. So the critical numbers are actually positive 2 and negative 2. And we can check indeed when x is less than positive 2, y prime is positive, because 4 minus x squared is going to be positive. When x is larger than 2, y prime is going to be negative. And the coordinates of the maximum point are therefore 2, 12. Remember from the first derivative test, if a function changes from increasing to decreasing, the function has a local max at x equal to 2. Has a local max at the critical number where the function changes from increasing to decreasing. Okay, so let's go to the next question. Find all x coordinates for all x coordinates of points on the curve where the tangent line is horizontal. So if you recall, a horizontal tangent line means y prime has to be 0. Right? So if y prime is equal to 0, that means y prime equals 7. That means we need to first compute y prime and then set it equal to 0. So equals 7 times, so minus 8 to the 6 times, let's go with the numerator, times the denominator, x minus 4 to the 5th, all over 5 times x minus 4, the 4th power, times x minus 8 to the 7th power. Now notice we're dividing this whole thing by x minus 4 to the 10th power. 5 times 2 is 10. So raising this denominator to the 2nd power is going to give us x minus 4 to the 10th power. So these will end up canceling with the term, the the factor in the denominator here, x minus 4. And what we're left with is just fact. Each term in the numerator had a factor of x minus 8. So the only place where the tangent line is going to be horizontal, one place is x equal to 8. The other place is, let's see, in the expression. So we have 7 x minus 8 to the 6 times x minus 4 to the 5th power minus 5 times x minus 4 to the 4th power times x minus 8 to the 7th power. All over x minus 4 to the 10th power. So what do we end up with? What do we end up with if we factor out x minus 8 to the 6th? Well, we can factor in x minus 8 to the 6th, and also in x minus 4 to the 4th. We end up with 7x minus 4, or 7x minus 28, minus 5x plus 40. So we're left with 2x plus 12, right? Negative 28 plus 40 is positive 12. And we set this term equal to 0, so we can see, okay, x minus 8, that's equal to 0. X minus 4 is equal to 0 too, but remember we have in x minus 4 to the 10th power in the denominator, so those terms are going to cancel. We're going to really be left with x minus 6, x minus 4 to the 6th power in the denominator. Root 2x12 is 0. That means that x equals negative 6 is another input value where y prime is equal to 0, or equivalently where the tangent line is horizontal. And these are our two values. X is equal to 8 and x is equal to negative 6. The function h is defined in terms of a differentiable function f of x. Equal to f of x plus 6 divided by x, write an expression for h prime of x. Now this is going to require the use of two rules. First rule is the quotient rule, because this is the quotient of two functions, a numerator divided by a denominator, and also the chain rule in order to differentiate the outside function f evaluated at the inside function x squared. So to find h prime of x, we get h prime equals 6 times x to the 5th times f prime of to the 6. This is the numerator times the denominator, this is times x. So these two factors combine to get 6x to the 6. Times f prime evaluated at x to the 6 minus f of x to the 6, the numerator, times the derivative of the denominator. Derivative of the denominator is 1, all over the denominator squared. And there we can see which of these 4 answer choices matches our expression. It's choice D. H prime is 6 times x to the 6 power times f prime of x to the 6 minus f of x to the 6 power all over x squared. So this is the derivative of the numerator times the denominator minus the numerator times the derivative of the denominator, which in this case is 1, all divided by the denominator squared. Next question is to find the equation of a tangent line to the graph of this function at the point 2, 4. To differentiate this function, we need to use 2 rules. One is the product rule. The other is the generalized power rule, which is really just a specific case of the chain rule. Now, so let's differentiate this function. We get y prime is 2 times, that's the derivative of, so this is the product rule, derivative of the first factor, which is 2, times the second factor left alone. Second factor left alone is x squared minus 4x plus 5 raised to the 8th power. Now we're going to add 2x times x squared minus 4x plus 5 raised. So when you differentiate the second factor, what do we get? So remember, the first term here and the derivative is going to be y prime equals 2 times x squared minus 4x plus 5 to the 8th power plus 2x times 8 times x squared minus 4x plus 5 raised to the 7th power times 2x. So it's the same, we can factor on x squared minus 4x plus 5. Raised to the 8th power, or actually, I'm sorry, not raised to the 8th power, raised to the 7th power. So we can factor out x squared minus 4x plus 5 raised to the 7th power plus 2 plus 8 times 2x times x squared minus 4x plus 5. Now when x is equal to 2, we get 8 times 2x, that's the same as 4, so this becomes 8 times 4 times x squared minus 4x, that's the same as 4 minus 8. 4 minus 8 is, so 4 minus 8 is negative 4 plus 5 is positive 1. So what we end up with is 2 times 1 all right, 1 so recall here when we factored out 2 times 1, remember this was to the 8th, plus, now this 8 came down, so 8 So if you recall here, the original expression for y prime, when we factor out x squared minus 4x plus 5 to the 7th power, we multiply by 2, what's inside is 2 times x squared minus 4x plus 5 plus 8 times 2x. So that's what happens when we factor out this expression here raised to the 7th power. Now when we plug in 2 here, we end up with inside. Remember, what's outside here, what's inside the parentheses here becomes 1. What's here becomes, this also becomes 1. 4 squared minus 8, 4 minus 8, which is negative 4 plus 5 is 1. When we plug in 2 here, what we end up with is 8 times 2 times another 2. That's the same as 8 times 4, which is 32. So end up with 32 plus 2, which is 34. So I'm pretty sure this should have been y minus 4 equals 34 times x minus 2. So because the slope here isn't 2, it is 34. I'm sorry, actually, what's inside the parentheses here is y prime. Once we have this x squared minus 4x, the sum power factored out, what we're left with is the following. Two x. We're left with 2 times x squared minus 4x plus 5. Now we're also left, okay, so when we differentiate, so we're also left with an 8 times 2x times 2x minus 4. So notice this is 16x. So this actually becomes 32x minus 16 times 4. So that's 64 minus 64. And we're adding 2. When you plug in 2 here, 32 times 2 is 64, minus 64 is 0, plus 2 is 2. So indeed, the slope is equal to 2. I apologize for the error. Slope m equals positive 2. So what we're left with is y minus 4 equals 2 times x minus 2. So y is 2 x minus 4 plus 4. 2x minus 4 plus 4 is equal to 2x. So the 4's cancel, we're left with the equation of the tangent line, y is equal to 2x. Okay, so again, what's important is the same procedure. The slope m is going to be equal to y prime. Use implicit differentiation of equation to determine the slope of the graph at a given point. So here, to use implicit differentiation, remember, we treat y as an unknown function, but they're still differentiable function at x. So when we differentiate y squared, what we're left with is 2 times y times y prime which is equal to 6 times x squared. There. Now we need to plug in x is equal to 2 and y is equal to -5. Now notice when x is equal to positive 2, this expression on the right becomes 6 times 4, which is equal to 24. So we're left with 24. And this expression on the left becomes -10. So we're left with -10 times y prime equals 24. That means y prime equals -24 over 10, which is the same as -24 over 10, which is the same as -12 over 5. That's the slope of the tangent line to this curve at the given point, 2, -5. So slope of the tangent line and slope of the graph, they mean the exact same thing. Next question is to use implementation of the equation below to determine the slope of the graph at the given point. X times y to the fourth equals -49. X is -1 over 49, and y is -7. So we first determine dy dx, and this is to determine dy dx, we need to use the product rule. The derivative of the left-hand side is just going to be y to the fourth plus 4 y cubed times y prime times x equals 0. What does that mean? That means y prime is equal to negative So remember, what was in front of y prime? It was 4 y cubed times, the coefficient of y prime was 4 y cubed x times y prime. If we bring the other term, which is just y to the fourth to the right-hand side, we get negative y to the fourth. Now we divide both sides by 4y cubed times x. So we divide both sides by 4y cubed times x. What do we get? We get negative 4 y cubed times x, so which is the same as negative y over 4 x. When x is negative 1 over 49 and y is negative 7, what we're left with is negative 7 divided by 4 times negative 1 over 49. So it's negative this whole thing. These negatives cancel. This negative stays outside. So when you take the reciprocal of 1 over 49, you just get 49. So we're left with 49 times 7 over 4. 49 times 7 is 300. And we should be negative out front here. Negative. So we should end up with is 343 over 4. Slope of the graph at the given point, equivalently, the slope of the tangent line to the graph at the given point is negative 343 over 4. Find the value of x at which the function has a possible relative max or relative min point. Recall e to the x is positive for all x. Use the second derivative to determine the nature of the function at these points. So here, what you're required to do here is to differentiate this function and then determine the critical numbers. Now, to do that, let's find f prime. F prime in this case is equal to what? We're going to use the product rule because this is the product of two functions. The first function being f plus x, the second function being e to the minus 3x. Let's see. The derivative of the first factor is just 1, right? Derivative of 5 is 0, derivative of x is 1. So what we're left with is e to the minus 3x plus negative 3 x plus 5 times e to the minus 3x, because the derivative of e to the minus 3x is negative 3 e to the minus 3x. We can factor on e to the minus 3x here, so what we're left with is 1 minus 3x minus 15. We're multiplying that by e to the minus 3x. So that's the same as 16 1 minus 15, which is sorry, it's not negative 16, it's negative 14 minus 3x times e to the negative 3x equals 0. What does that mean? That means that x equals, so this becomes negative 14, the coefficient here is negative 14 minus 3x I'm multiplying this by e so the derivative we have is negative 14 minus 3 times x times e to the minus 3x. That's equal to 0. If this is 0, because e to any power is always positive for all real x, that means the only way this is ever going to be 0 is that this factor, negative 14 minus 3x, is equal to 0. That's 0 precisely when x is this number, negative 14 over here. That just comes from dividing. We say negative 14 minus 3x equal to 0, we end up with x being negative 14 over 3. And the critical numbers, as we saw, are where functions have potential local max, equivalently relative max, or relative mins. To determine whether or not this is a relative max or min, we are asked to use the second derivative test. Now, what do we find? We found that f prime is equal to negative 14 minus 3x times e to the minus 3x. What's f double prime? It is same thing. We use the product rule, negative 3 times e to the minus 3x plus 3 times 14 plus 3x times e to the minus 3x. So what's that equal to? That is equal to e the negative 3x. 3 times 14 is 30 plus 12, which is 42. So we get 42 minus 3, which is 39, minus 3x. So it's 39 minus 3x, e to the minus 3x, times 39 minus 3x. So 39 So 39 minus 3x times e to the minus 3x. Now we're going to plug in x equal to negative 14 over 3. This becomes negative 14. We get 39 plus 14. 39 plus 14 is positive. So we end up with positive number. So we end up with, and the point is really we have positive number. So I believe that was a small error. We should have gotten a negative number because we have a maximum. So f prime is equal to negative 14 minus 3x times e to the minus 3x. Negative 3 is negative 3 e to the minus 3x plus negative 3 times negative 14 minus 3x. So we distribute this here. This is positive. This is also positive. We get, I'm sorry, so we get 9. That's right. It's 9x plus 39. So f double prime equals 9x plus 39 raised to times e raised to the negative 3x power. So 9 times negative 14 over 3, that's the same as 3 times 14, rather negative 3 times 14, which is negative 42. Well, we just saw negative 42, 42 is larger than 39. So negative 14, negative 42 plus 39, therefore, is going to be equal to negative 3. We're multiplying by e to some number, in this case negative 3 times negative 14 over 3. Whatever that e to that raised to the power is negative, so negative 3 times that number is therefore negative, meaning we have a relative maximum. So remember, f double prime being negative means our function is concave down. And in this case, concave down looks like an upside down smile or a frown or hill. And that means that the critical number is, in this case, corresponds to a local maximum. A hill has a top, frown also has a top. Okay, this next question is pretty straightforward. Just differentiate this function. Well, differentiate this function. We can leave 2 alone. That's just a constant. Remember, the constant multiple rule says the derivative of a constant times a function is equal to the constant times the derivative of that function. And to differentiate e to a function, it's the same as e to the function times the derivative of that function. So in this case, what we're left with is 2 times, what's the derivative of x over 2? It's just 1/2, right? The derivative of any constant times x is that constant. So 2 times 1 over 2 times e to the x over 2, which is equal to e to the x over 2, because 2 and 1/2 cancel. So we're left with 2 times 1/2, which is just 1, and we're left with e to the x over 2. So we have we have 11 more questions to go. This is question 20 out of 30. Same question here. Find the derivative of this function. So to find the derivative of this function, remember the setup. Differentiating e to a function, the inside function is what's in the exponent. The outside function is e to that exponent. So the chain rule says the derivative of e to the stuff, e to a power, is going to be e to the stuff, e to the power, times the derivative of that power. Here the outside function is e to the power, the inside function is square root of x minus 19. So its derivative is e to the square root of x minus 19 times the derivative of square root of x minus 19. And when we differentiate square root of x minus 19, now what's the inside function here? It's x minus 19. The outside function is the square root function. If you recall, the derivative of the square root function is 1 over 2 times the square root function. And now we need to multiply by the derivative of what's inside. The derivative of x minus 19 is just 1. So we're left with 1 times e to the square root of x minus 19 over 2 times square root of x minus 19. Okay, this next question is asking you to write the equation of the tangent line to the graph of the following equation at x equal to 0. Y is equal to ln of x to the 8th plus e. What is the equation of the tangent line to the graph at x equal to 0? So to do this, we need to differentiate the function to find m, the slope. In this case, y prime is going to be, so how do we differentiate ln? We differentiate ln of the function by differentiating the function inside and dividing by the function inside. In this case, the derivative of the function inside is 8 times x, 8 times x to the 7th over x to the 8th plus e. So when x is 0, 8x to the 7 is just 0. So we're just left with 0 over, it doesn't matter what we have in the denominator, 0 over anything is 0. As long as we have denominator is not 0. And indeed, it's 8, 0 to the 8th, which is 0, plus e, which is also 0. So we're left with 0 divided by e, which is equal to 0. That means that our slope is going to be 0. So the slope of the tangent line is 0. And the equation of the tangent line to the graph at x equal to 0 is y minus, well, what happens when x is 0? What is the output corresponding to the input at x equal to 0? When x is 0, y is equal to 1. So y minus 1 equals 0 times x minus 0. Point slope formula. That means that y is equal to 1. So if x is equal to x minus 0, 0 times x minus 0, that's equal to 0. Y minus 1 equals 0 means y is equal to 1. So the equation of the tangent line of the graph at x equal to 0 is y equal to 1. Again, same format for finding the equation of the tangent line. We need to find the slope, which in this case was 0, and we also need to make sure we find our point. When x is equal to 0, the output is 1. So we're determining the slope, the equation of the tangent line to the graph at the point 0, 1. We have a slope 0 and a point 0, 1, and from that we can use the point slope formula, y minus y1 equals m times x minus x1, to determine the equation of the tangent line. Next question. This is very similar to a previous question, but now we have a function that is written in terms of natural log of the numerator. Our job is to determine the coordinates of the maximum point of this function, y is equal to 8 ln of x plus 8 over square root of x. Well, we can see from the graph here that there's only one maximum point when x is larger than 0. And in fact, this function is only defined when x is larger than 0 because both ln and square root of x are only defined when x is larger than 0. So let's differentiate this. When we differentiate this, what we end up with is the following. 8 over x, that's the derivative of the numerator, times square root of x, that's the denominator, minus 8 ln of x ln of x plus 8 times 1 over 2 root x. Now let's see what we can do here. Well, 8 over x times root x is the same as 8 over root x. So we can actually factor out a 1 over root x here from both terms in the numerator. What are we left with? We're left with an 8 Now here, this is 8 divided by 2, so we're left with an 8 minus 4 ln of x, all over x, which is the same as square root of x squared. 8 minus 4 is 4, so it's 4 minus 4 ln of x over x, and x is equal to e. This numerator is 0, right? So remember, if we set 4 minus 4 ln of x, equal to 0, that means that x equals e. Because x is equal to e, or e to the first power, there's our critical number. Now when we plug in x equal to e into this expression, what do we get? Ln of e is 1. 8 plus 8 is 16. Square root of e is e to the half. So that's why the maximum point is e to the first power, comma, 16 over e to the 1/2 power. Now, how do we know this is a maximum point? Well, it turns out, okay, remember what we had was 4 minus 4 ln of x. Now, if x is less than e, 4x, this term, is going to be less than 1. That means the expression is going to be larger than 0. But if x is larger than e, this expression is going to be larger than 1. And so 4 minus 4 ln of x is going to be less than 0. So we have put this in the real number line. We have an e here. We have a 0. We have a y. Prime. Positive here. Negative here. Because y prime changes from positive to negative, the function is changing from increasing to decreasing, so we obtain a local maximum at x equal to e to the first power. Next question is to use logarithmic differentiation to differentiate the following functions. So here, the function is x plus 7 to the third power times 3x minus 2 raised to the fifth power. Now, how does logarithmic differentiation work? ln, we take ln on both sides. Let's ln of the left-hand side is just ln of f. And then when we take ln of the right-hand side and simplify using the logarithms, so what happens when we take ln of the right-hand side? We get ln x plus 7 raised to the third power times 3x minus 2 raised to the fifth power. What's that the same as? That's the same as ln of x plus 7 raised to the third power plus ln of 3x minus 2 raised to the fifth power, which is the same as 3. So this is just the fact that ln of a product, because the sum of ln of each factor, and now these power comes down, 3 times ln of x plus 7 plus 5 becomes 3 ln times ln of x plus 7 plus 5 times ln of 3x minus 2. Differentiate this. What do we end up with? We end up with 3 over x plus 7 plus 15, right? The derivative of ln of 3x minus 2 is 1 over 3x minus 2 times 3. 15 over 3x minus 2. And then times x plus 7 raised to the third power times 3x minus 2 raised to the fifth power. And why do we have that? Well, that's because, remember, on the right-hand side, on the left-hand side, it's f prime over f. The derivative of ln of f is f prime over f. That's equal to this expression. F is just this expression, x squared, x plus 7 third power times 3x minus 2 to the fifth. So when we solve for f prime, we have f prime over f equals this expression. And then when we solve for f prime, we just move f to the right-hand side. So we're left with f prime being equal to f times this whole expression here. And then what is f? It is x plus 7 cubed times 3x minus 2 to the fifth times this expression. So that's why the final answer for using logarithmic differentiation to differentiate this function is the original function times this expression 3 over x plus 7. That came from differentiating 3 times ln of x plus 7. That's what happened to this factor raised to the third power when we took ln of this whole expression. And then plus 15 over 3x minus 2. That's what happened to this expression, the second factor, when we took ln of 3x minus 2 raised to the fifth power. We're left with 5 times ln of 3x minus 2. Its derivative is 5 over ln minus 5 over 3x minus 2 times 3. 5 times 3 is 15. Okay. Next question asks us to evaluate an indefinite integral. Indefinite means it does not have a lower bound or an upper bound. Now, this is equivalent to the antiderivative. To find the antiderivative of this function, or square root of x minus 1/2 square root of x, what we can do is just rewrite this as 4 times x to the 1/2 minus 1/2 times x to the negative 1/2. So what's 4x to the 1/2? That's the same as 4 times x to the 3/2 all over 3/2. And of course, the reciprocal of 3/2 is 2/3. 2/3 times 4/1 is 8/3. So we're left with the first term being 8/3 x cubed x to the 3/2. The antiderivative of this term now is we have 1/2 times x to the 1/2 over 1/2. So we're subtracting. We can anti-differentiate term by term. The antiderivative of 4 squared of x is the same as 8/3 x to the 3/2. The antiderivative of 1 over 2 squared of x is the same as x to the 1/2. And then we just add this integration constant c. So remember the antiderivative of, this is important, anti-differentiation formula. It's in the lecture slides I gave about antiderivatives. The antiderivative of x to the r, for r not equal to -1, is equal to x to the r plus 1 over r plus 1 plus a constant. So what's going on here is we anti-differentiate each term using the power rule for antiderivatives. Remember, this is doing the power rule for derivatives backwards. Antiderivative of 1 over 2 root x becomes x to 1/2, and we add the constant c to the equation. Same thing here. We're going to anti-differentiate this function. The antiderivative of 6 over 5 x to the 5th is going to be the same as 6 over 5 x to the 6th. So now we add 1 to the exponent and divide by that exponent. So the antiderivative of 6/5 x to the 5th is the same as 6 times x to the 6th power over 5. So 6/5 x to the 6th power all over 6. These 6's cancel, so what we're left with is just 1/5 times x to the 6th power. So we can see here, okay, the antiderivative of 6/5 x to the 6th power is the same as 1/5 times x to the 6th power. Now, the antiderivative of 4 times e to the -2x. Remember, the antiderivative of e to the kx. So there's a formula here that says the antiderivative of e to the kx is equal to e to the kx over k plus a constant. E to the kx. In this case, our k is -2. So we're multiplying 4 times e to the negative 2x over negative 2. That's the same as negative 2 times e to the negative 2x. Negative 2 to the negative 2x. Second term, negative 2 to the negative 2x. First term, antiderivative becomes 1/5 x to the 6. So antiderivative of the first term is 1/5 x to the 6. Antiderivative of the second term is negative 2 times e to the negative 2x. And of course, we add this constant of integration, c. Okay. So that was just another indefinite integral or antiderivative. It's equivalent to finding the most general antiderivative. That's what an indefinite integral means. This, however, is a definite integral. And to evaluate it, we need to first find the antiderivative of this function. And here, because we're evaluating at the upper bound and the lower bound, we're evaluating a definite integral, we don't have to worry about the integration constant, or constant of integration c. So here the antiderivative is x cubed over 3 minus 2 times x to the negative 2 all over negative 2 plus 3x. We evaluate this. Let's see first what this reduces to. This reduces to x cubed over 3 plus x negative 2 plus 3x. We'll evaluate at negative 1 and at negative 2. When we evaluate at negative 1, we get negative 1 over 3. When we evaluate at negative 2, we get 1. When we evaluate at 3x, we get negative 3. So this becomes, let's see, it's negative 1/3 plus 1 minus 3. 1 minus 3 is negative 2. So when we evaluate the antiderivative at the upper bound, we get negative 1/3 plus 2. Negative 1/3 plus 2 is just, so that's the same as 6/3 minus 1/3. So it's the same as 5 over 3. That's the antiderivative evaluated at the upper bound. The antiderivative evaluated at the lower bound, what is that going to be? Well, that's going to be q cubed over 3 plus 2 to the negative 2, or 1 over 2 squared, plus 2 this was negative 2. So recall the antiderivative as we found it was x cubed over 3 plus 1 over x squared, or x to the negative 2, plus 3x. When we plug in negative 2 here, when we plug in this lower bound, we get negative 8, right? 2 cubed is 8, negative 2 cubed is negative 8, divided by positive 3, plus 1/4 minus 6. So, what is that? Let's see. It's negative 8/3 plus 1/4. Well, 1/4 is the same as negative 8 divided by 3 plus 1/4. That's the same as, let's find a common denominator here. Common denominator is 12. So negative 8 times 4 is 32, so it's the same as negative 32 twelfths. And this is the same as 3 twelfths. Negative 32 plus 3 is the same as negative 29. So negative 29 that's negative 29 over 12. And now we're subtracting 6. That's the same, well, that's 6 twelfths. That's the same as 72 twelfths. So that's 72 let's see, we have negative 72 and then what's really going on here, right, is we're adding not adding, but we're 5/3 is out here. 5/3 is how many 12? That's 20 twelfths. So we have 20 twelfths minus, let's make sure this is right here, is negative 8 over 3 plus 1 over 4 minus 3 times 2 is 6, minus 6. Okay. This becomes negative 30 2/12 is 3/12 minus 6 times 12 is 72. So I believe so this should be, I feel like what we should be getting is negative 9 minus, we should be getting is 9 plus 73, which is 85, but that's not an answer choice here. So let's try to get something like that. X cubed over 3 plus x to the negative 2 plus 3 x. Plug in 1, we get negative 1, we get negative 1/3 plus 1 minus 3. That's the same as negative 1/3 plus negative 2, which is the same as, okay, there we go, that was negative 7 over 3. So now we can see why it turned out. Negative 7 over 3, how many? So it's negative 7 over 3. Well, what's negative 7 over 3 written with 12 in the denominator? Multiply both numerator and denominator by 4. What do we end up with? We end up with negative 28 over 12 and then we're adding 29. We saw that before, it was 29 over 12 plus 72 over 12. So that becomes 29 plus negative 28 is positive 1, so we're left with 1 plus 72 over 12, which is the same as 73. Over 12. So this is the same as 73 over 12. Okay, this next definite integral, same procedure. We're going to anti-differentiate the integrand, which is 18 over x. What do we do? What happens when we do that? We get 18 times ln of x of 1 over x, ln of x. We're going to evaluate it at e and at 1. If you recall, the antiderivative evaluated at ln evaluated at e is always going to be 1, and ln evaluated at 1 is always going to be 0. So what happens? We end up with 18 times 1 minus 18 times 0, which is equal to 18. So there's our answer. Find the area under the curve. Y is equal to e to the x is equal to -2, and x is equal to 6. So here, all we have to do is set up this integral. The integral of e to the x, we're setting up a definite integral. The definite integral of e to the x, as x ranges from -2 to +6. Remember, the antiderivative of e to the x is e to the x. So we're going to evaluate e to the x at +6 and at -2. And then we're going to take the difference of those two values. This vertical line, by the way, just means evaluate this function at the upper bound, and then subtract, think of this as a big subtracting sign, the function evaluated at the lower bound. So what we end up with is e to the 6th power minus e to the -2nd power. That's the same as e to the 6th power minus 1 over e squared. E to the 6 minus 1 over e squared. Write down the definite integral or sum of definite integrals that gives the area of the shaded portion shown below, or shown to the side in this case. So here, as you can see, f is positive when x is between 1 and 2. So the definite integral of this function when x is between 1 and 2 gives you this area here. So of these choices, we can definitely eliminate answer choice B, because this says we're including the definite integral of the negation of this function when x is between 1 and 2. But when x is between 1 and 2, the function is positive, not negative. So the definite integral, this definite integral from 1 to 2 of the function will indeed give us the area under the curve. Same thing here. This will definitely give us the area under the curve. Now, when x is between 2 and 4, the function is negative. That means the negation of the function put in the integrand of the definite integral between the bounds of 2 and 4 will give us the area of this second blue region here. And that's why answer choice A is correct, because the definite integral of the function between the bounds of 1 and 2 gives us the area under the curve between 1 and 2. However, because the function is negative, the definite integral of that function when x is between 2 and 4 will give us the negative, the signed area, the negation of the area under the curve, negation of the area between the x-axis and the curve. So in other words, if we evaluate definite integrals, if we were just evaluating definite integrals, this signed area would be positive, this signed area would be negative. To make this positive, we have to negate the function f. And that's why f is negated when x is between 2 and 4. So the correct answer is, correct expression is the definite integral of the function when x is between 1 and 2 plus the definite integral of the negation of the function when x is between 2 and 4. Okay. Find all points x comma y where f of x comma y has a relative maximum or minimum. Then use the second derivative to determine, if possible, the nature of f at each of these points. If the second derivative test is inconclusive, so state. So here our function is negative 2x squared plus 5xy minus 11y squared minus 3x plus 9 minus 2. The derivative of the function with respect to x is negative 4x. So what does it mean to do df partial f partial f? Partial f partial x. That means y is constant here. So this is differentiated as we normally would differentiate it because there's no term or factor of y. Derivative of this, remember y is constant. So this is really just saying 5 times y times x. Derivative of a constant multiple of x is that constant multiple. In this case, 5y. Derivative of 11y squared is just 0. Derivative of minus 3x is just minus 3. So we're left with negative 4x plus 5y minus 3. That's the partial of f with respect to x. The partial of f with respect to y is the same thing, but now we would treat x as a constant. This is constant. This, its derivative is just 5x times y, so its derivative is 5x, coefficient of y. Derivative of negative 11y squared is negative 22y. This is constant because it does not depend upon y. 9y, its derivative is just 9. And of course, 2 is a constant, so its derivative is going to be 0 for both the partial with respect to x and the partial with respect to y. Now, using only the first derivative test for functions of two variables, find all points that are possibly a relative maximum or relative minimum. To do that, we set this equal to 0. So we set negative 4x plus 5y equal to 3. And 5x minus 22y equal to negative 9. We're going to solve this system. To solve this system, we can multiply, okay, so it's negative 4x. So what we're really doing is setting both these equal to 0. The first partial with respect to x equal to 0, and the first partial with respect to y equal to 0. And we want to solve for, let's say we want to solve for y. Well, we can multiply this first equation by 5 to get negative 20. negative 20x plus 25y equals 15. $25x. Now, so we're multiplying the first equation by 5 and the second equation by 4. Negative 20x plus 25y equals 15, and 20y minus 88 20x minus 88y equals negative 9 times 4, which is equal to negative 36. So 25 y minus 88y minus 88y equals 15 minus 36. That's negative 9 times 4. 15 minus 36 is the same as negative 21. So that's the same as negative 21. 25 minus 88, that's the same as negative 63. So we're left with negative 63y equals negative 21. We divide both sides here by negative 63. We end up with 1 over 3 because 63, 21 goes into 63 3 times. Now, when we plug in to say, let's say y is 1, this means y is 1/3. If we plug in y is equal to 1/3 into the first equation here, what are we left with? We're left with 4x plus 5 over 3 equals 3. This means that 4x is equal to 3 minus 5/3. So 3 is 9/3. Is the same as 9 minus 5/3. That's the same as 4/3. What was the coefficient of x? It was -4. Divide this by -4. We're left with x. We divide that by -4, we end up with -1/3. So we're left with -1/3, comma, +1/3. Find all the points x, comma, y found earlier at which f of x has a relative minimum. Select the correct choice below, and if necessary, fill in the box to complete your choice. So to do this, so what we really should do here before going on actually is do this step here. Compute d of x, comma, y. D of x, comma, y ends up being 63. In this case, that's because if you look at what's df dx squared, it's -4. What's df dy squared? It's positive. So df dx squared is -4. That's mixed partial with respect to x. Mixed partial with respect to y. So I'm sorry. The second partial with respect to x is -4. Second partial e squared dx squared equals -4 d squared df dy squared equals -22 and d squared dx dy equals d squared dx dy equals +5. So we have, so to compute d, right, that's the next part, the second partial with respect to x, which is -4, times the second partial with respect to y, which is -22, minus the square of the mixed partial, which is in this case -5, so we'll subtract 25. So we get 88, -4 times -22 is 88. 88 minus 25 is equal to 63. So 63 is positive, and if you -1/3 and -1/3, comma 1/3, the second partial with respect to x, actually the second partial with respect to x is always negative. So that means we have a local minimum. negative second partial with respect to x, and a d that's positive implies a local minimum. So relative maximum, because the f dx squared so remember, what do we say? D squared df dx equals negative 4, which is negative. So, and our d is positive. Positive d and a negative second partial with respect to x means local max. So again, d being positive just tells you that the function is, this function two variables is curving inwards. The fact that df dx squared is negative means it has the shape of a ball, but it's facing downwards, and therefore has a local max. So they ask you in the next question, find all points x, y found earlier at which the function has a relative min. Select the correct choice below, and if necessary, fill in the box to complete your choice. The relative max min occurs at, where do they occur at? Well, there's no minima, right? There's no minimum. There's only a local maximum at this point, negative 1/3, 1/3. The relative maxima, however, does occur at negative 1/3, 1/3. Find the points at which has neither a local min nor a local max. Select the correct choice below, and if necessary, fill the answer box to complete your choice. So here, no, there's no saddle point, because a saddle point would mean that d, this algebraic expression involving second partials, is negative. Compute d, that's negative. Well, there's no d that's negative. D is always 63, which is positive. So there's no saddle points. And there's also no points where it's inconclusive. So inconclusive would mean d is equal to 0. Are there any points where d is 0? No, d is just this constant that's 63, which is always positive. Now, you have to remember, if d did in fact contain, did depend, here d was a constant, did not depend upon x or y. If d did depend upon x or y, it would be necessary that you plugged in this critical number, or if there was more than one critical numbers, this critical number, or potentially more critical numbers, into the expression d of x, y. Okay, so that's it for reviewing the practice exam. Best wishes for the actual exam. You have until Sunday to do it.